The slide changed also, right?
Yeah.
Yes, it's update.
Yeah, so physical and chemical changes are our topic. So at the end of this presentation, you will be able to understand about the types of physical changes, the science of chemical change, the energy transfer during physical and chemical change, the reversibility in these changes, and at last the summary.
Good.
So as you already know about what is physical and chemical change, let me check if you are able to answer this question. During burning of a candle, both physical and chemical changes take place. So can you distinguish which are those changes in the burning of? Yeah.
The melting is a physical change, that is the same substance, that is the candle is being melted, while the chemical change that occurs is the presence of different types of gases like carbon dioxide and all that is being exposed to the air.
Yes, yes, you're right. So the physical changes, as Srimai already told, the wax is what is getting melted due to the flame and forms a liquid wax. So can you get this liquid wax back into the solid form?
Yes, when it get dried.
Yes, so it is reversible, right?
Yes.
So it is a physical change. Now the chemical change in detail is when you light the candle, the wax which is present near the wick, this is the wick of the candle, the wax which is present near the wick of the candle vaporizes, and due to the heat produced, because due to the heat produced by the flame, this wax vapor near the flame burns and gives new substances like carbon dioxide, carbon soot. You can see this black color, it is the soot formed, the water vapors, heat and light. And as this is an irreversible change, it is a chemical change. Got it?
Yes.
Okay. So the first objective types of physical changes. First is change in shape. Twisting, bending, tearing of paper, shredding, breaking, crushing, pulverizing, which is another word for crushing, stretching, squashing, all these ways are the shape that can change the shape of a substance by applying force. Is a Coca-Cola can made like this? Is it manufactured like this? No, right? It is made like this. But when you apply force, maybe under your foot or when a car passes through it, it becomes this shape. But only the form of the shape or the form of the substance is changed. But there is no new substance that is forming or no new chemical reactions or changes that is taking place. So they may result in substance looking different, but they remain the same substance, just in a different form. Next is change in states of matter. The most common states of matter is solid, liquid, and gas. So the 6 types of changes are melting. You know, your ice cream melts. That's the best example. Freezing, which is the exact opposite of melting. You keep water in the freezer to get the ice cube. Vaporization. This is called vaporization when liquid changes into vapors. You know condensation, you have heard about evaporation, condensation and precipitation. The water evaporates and then it condenses, which means that the evaporated vapors turn into liquid form and they become heavy and precipitate. So what does condensation mean?
Gases turning into liquid form.
Yes, the vapors turning into liquid form. You might have observed in a glass, you pour water and put some ice cubes. You will see small drops of water forming in the glass. It is because the air come in contact with the cold surface, and the air is changed into liquid form. Which is the condensation and vaporization are just opposites. And same like that, sublimation and deposition. Sublimation means the ice, the solid turning directly into gas form without taking the form of liquid. The best example is a dry ice, which changes directly into gaseous form. Deposition, which is the exact opposite of sublimation. So it will obviously be the vapors changing into solid form. The best example is frost, which is formed in leaves. You can, in cold areas or cold times, you can see small ice or frost that is formed in the leaf, it is due to the deposition. All these changes take place because of change in temperature or pressure. The next objective, signs of chemical change. First one is color change. A color change may indicate that a new substance has been formed. Rusting of iron, as Srimai already told, ripening of fruit, bleaching of hair, burning of toast. Is it reversible? Can you get the original form of bread after burning? No,
No.
right? So it is a chemical change, but it doesn't mean that all color changes are chemical change. For example, we mix blue and yellow paint to get green color, but still separate blue and yellow pigments exist. Next is formation of bubbles or odors. Odors means smell, right? Bubbles or odors may indicate that a new substance has been produced. Fizzing, when acid comes in contact with metal, the smell of rotting rubbish, the fumes from a car exhaust. But it doesn't mean that all bubbling and odors are chemical change. Just this is the best example. For example, the bubbling that occurs when a substance boils or the smell of a substance when it vaporizes are both the result of physical change. Next is the temperature change. Chemical changes involve the transfer of heat energy, resulting in an increase or decrease in the temperature. Sometimes it releases heat, which is also accompanied by light or sound. Burning of coal in a steam engine and igniting fireworks are some examples of temperature change. But it also, like I said before, it doesn't mean that all temperature changes are due to chemical change. Next objective, energy transfer during physical and chemical changes. All chemical changes involve energy changes and the transfer of heat. Depending on the particular example, energy can be released or absorbed. So there are two types of changes, exothermic and endothermic. When the energy is released, it is known as exothermic. Exo means releasing. You can remember it like that. Energy is released in the form of heat, but it is also accompanied by light or sound. As a result, the surrounding environment also experiences an increase in the temperature because the energy is being released. And the new substance which forms contain less chemical energy than the original form. Next is the endothermic chemical change. It is obviously when the energy is absorbed. Endo means inside, so you can remember it like that. Heat energy is absorbed from the surrounding environment. So when heat is absorbed from the environment, the surrounding area will be much colder. Since energy is absorbed, the new substance contains more chemical energy than the original substance. Physical changes can also be exothermic or endothermic. Next is the reversibility of physical and chemical changes. Most physical and some chemical changes are reversible. Generally, physical changes are easier to reverse. This is because the physical processes do not need much energy than the chemical processes because they do not involve any breaking of chemical bonds. On the other hand, the formation of rust, the burning of propane gas could all be reversed but would require immense chemical processes and much more energy. This is a dent formed in a car. Can you reverse this dent?
Yes.
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 By beating out the metal, you
Yes.
can, yes, you can
Yes,
get
we
the
can.
original form. Yes, this is the melting of an ice cream. If you freeze this, obviously you will get the ice cream back. This is adding salt to the water. You can get the salt by evaporation, and the shredding of paper, everything, these all are reversible as the chemical bonds are not being affected like a chemical change. Now we come to the summary. So physical changes involve changes in the appearance of the substance, but the type of substance does not change. Chemical change involves the formation of one or more new substances. So the physical changes can involve change in shape, change in state of matter, and the chemical changes can involve color change, formation of bubbles or smells, temperature change. The chemical changes involve breaking and forming chemical bonds between the atoms. Exothermic changes release heat energy, endothermic changes absorb heat energy. Most physical and some chemical changes are reversible. Generally, physical changes are easier to reverse than chemical changes as they don't require the breaking of chemical bonds. Thank you.